Hi, in this video we will study continuities of rational functions, the functions which are polynomial over another polynomial. Let me just write what is a rational function. Rational function is a function which is quotient of two polynomials, where P and Q are two polynomials. This class includes the polynomials. When you have the qx is equal to constant, this will be a polynomial. What we know about these guys is that first, these guys are defined everywhere but points which make the denominator 0. So let me just write domain of px over qx is the whole all real numbers, but the roots of the denominator. Denominator here is qx. So it's everything but wherever x is 0. Qx is 0. And another fact that we learned was, we called it a direct substitution property, that when you're trying to find the limit of these guys, wherever these guys are defined, the limit is given by just direct substitution. So direct substitution. These are facts from the basically rational basically laws of limit gives us this fact that for any a in the domain of f for this rational functions, limit of the function as x approaches to a is basically same thing as evaluating the function at that point. Well, let's combine these two and write it in the language of continuity. You see, first of all, this means that for all such a's, the function is continuous. That's the definition of continuity. Limit is equal to value of the function. Yes. That's the first thing. And on the other hand, it says that this is, all a's which makes the denominator non-zero. So we now know that this is a fact. Rational functions are continuous at every point in their domain. So every x you give me, which is in the domain of the rational function, the function will be continuous at that point. But we know that wherever that the function is not defined also, that fails the first condition of the continuity. It won't be continuous. So this means that the set of continuous points of f of x f of x, which is a rational function, is equal all x's at which qx is not 0. That's easy, yeah. Now as a side fact, we have, for polynomials the denominator is always non-zero. It's just a number. Px is polynomial. There's no denominator for polynomials. So that means that polynomials are continuous on at any real number. At any real number you give, a polynomial is continuous. For rational function, you have to check if that point makes the denominator 0 or not. If that's not making the denominator 0, that is a continuity point for the function. Okay, I have some examples. Let's see this in these examples. Find the set of points at which the given function is discontinuous. Here we have this one. The first one is a polynomial. Yes, polynomials are continuous everywhere. So this is continuous everywhere on real line. It's continuous. Polynomials are good ones. Always these are good functions. The second one says this guy. So what are the points at which the function is discontinuous? It says only find the zeros of the denominator. So discontinuous points for f. This is rational function. These are all the points which make the denominator 0. I'm writing discontinuous part. So it means that solve this guy. This is x equal to 1. There's only one point at which this function is not continuous. 1. How about this other one here? Well, again, discontinuous points for f. Well, you don't need to look at anything else. Just basically find the domain of whatever makes the denominator 0 if you're looking for discontinuities. This gives me x is plus or minus 1. So we have 2 points at which the function is discontinuous. As a result, well, this means that what? The f is continuous on everywhere but these 2 points. So from negative infinity to negative 1, from negative 1 to 1, and from 1 to plus infinity. For the other one, you get from negative infinity to 1, and then from 1 to plus infinity. And well, that's it. Just if polynomial is if a rational function is given, you just know where it is continuous, where it is discontinuous. Discontinuities are exactly where the denominator is 0. Just find those points, and that will give you everything.